piece of paper. 6x take 14. Okay. So these are my stationary points here, 4.09 and 0.56. So I'm going to say, okay, at x equals 4.09, I'm going to find out what my point is, and I'm going to find out what the nature of the stationary point is. So let's go with this one. So we've got y is going to be 4.09 cubed, take 7, 4.09 squared, plus 7, 4.09 plus 15. Someone could plug that into a calculator while I do the other one. And then we've also got, thank you, 6 times, this is our double derivative, 6 times 4.09, what does it take 14? And I'll do our other one too, x equals 0.56.
Negative 5.048.
So the y value?
Yeah.
Negative 5.048,
048.
so 05. Okay, so we've got our first point is 4.09 negative 5.05. Y dash is 10.54. So 10.54, now is that a positive or a negative number? That's positive, so it is a min. So this point here is a min. Do we have our ones for the second stationary point? What do you get? What did you get for it?
I don't know where I should be looking. But I think
What's the y value?
16.9.
16.9. That sounds like it could be right.
And double dash.
Hopefully it's a negative because
Yeah, I did it.
like negative.
Yeah, negative. I actually do the calculation.
What's the actual value for the double derivative here? Has anyone done that?
Huh? It's negative.
Looks like it should be about negative 12 or negative 11.
Yeah, negative 10.64.
Negative 10.64. So that's negative. So we have our point, which is 0.56, 16.9. Means we have and it's negative, the double derivative is negative, which means we have a max at that point there. Okay? And then so we've done those, so we'll also do our extremities. I kind of was slowing down for a bit. I just want to finish these extremities for the video. So then our extremities. So now we've got all our points, but I would really like to know, where does my graph come from and where does it go to? So from the negative x Does it come from a positive or negative? And if we go off to positive x, does it go positive y, negative y? So, which term are we interested in here when we're doing this? The largest term. So we have this x cubed here. Okay. So what we say is, we'll say, let's start with the negative x. So as x approaches negative infinity. So if we have our sketch, okay, as we're off coming from this end, okay, so the graph, we always think from left to right, is it coming from positive y or is it coming from negative y? So we look at our biggest term. Now our biggest term, we had a look at this when we did it. The biggest term has the biggest impact on whether it's positive or negative. Because if we make a very big x, the x cubed is going to have, it's going to be more than enough to cover any of these smaller terms. So if we give x a very big negative number, what is x cubed going to be? It's also going to be a very big and negative number. Okay? And because the x cubed, which is the biggest term, is very big and negative, the y is then very big and negative. So that means we come from negative y. Okay? So, and then as x approaches positive infinity, if we make x a very big positive number, what is x cubed going to be? It's going to be positive. Which means y is going to be positive as well.
So it's always going to be the same? Like y is going to be the
Y is always the same as the biggest term. Okay? We have to think from here to here, but then from here to here we're just copying down. Okay? But we need to show this here. Okay, so we can now put all our points in. So we had our y-intercept, which was 15. Our 3 x-intercepts, which was 3, 5, negative 1. This is obviously not to scale. Then we had our turning point. So our turning points were 4, which will be between these two, and negative 5. And our y's was 0.56 and 16, so some above that 15. And then we came from, so we could sketch that in. Okay, so it comes from negative x, negative y, goes off to positive x, positive infinity, and then we write in our coordinates. So negative 1, 0, 3, 0, 5, 0. We have a min at 4.09, negative 5.05, a max at 0.56, 16.9, and our y-intercept, which is 0.15. And that's all there is to it for our sketch.